So we spent time finding and solving a lot of different types of equations. And we just finished chapter 1 and now we're starting chapter 2. So chapter 2 gives us tools to graph. I am going to speed through some of this because it's graphing linear equations and plotting points and stuff like that. But if you have any questions, please feel free to stop me if you're in class. So let's just go through really quickly some terminology and information about graphs. And so I don't have the book in front of me, but I do have some papers. So let me just pull those up real quick. Okay, so when we're graphing, we're going to be doing it in 2D. And so we have the vertical axis is our y-axis. And the horizontal axis is our x-axis. If you have taken trigonometry, you'll know it's important to know what quadrants we have and the values of the signs of our points. If you haven't taken trigonometry, you'll be using that a lot. But we have 4 quadrants. We have the first quadrant, and they label them with Roman numerals. So we have the first quadrant here. Our points are always in the form where our x value is first and our y value is second. So in this first quadrant, our values of our x will be positive and our y value is also positive. We go counterclockwise instead of clockwise, so opposite direction. This would be our quadrant 2. You'll notice that our x values are going to be negative and our y value is still positive. So we have our third quadrant, both x and y are negative, and we have our fourth quadrant where x is positive and y is negative. If a point doesn't fall on a quadrant, it either falls on the x-axis or the y-axis, or it could be actually both. And so this point where the x and the y-axis meet, this is the point 0, 0, and it also has a special name called the origin. So you guys should be able to, and I really don't want to go through it that much, but if you should be able to plot points. And so let's say we have A is equal to the point 2, -3. So you should be able to tell me what quadrant that falls in. You should be able to plot it. And so let's just quickly do this. So I'm going over in my x direction over 2, and my y is -3, so I'm going to go down 3. And where those meet is where my point 2, -3 is. And so this falls in the fourth quadrant. So if you need me to, we can go through plotting more points, but if not, we're going to move on. Okay, so we're all set. We know how to plot points. We remember that's not too bad. But we're going to derive the distance formula. And in order to derive this distance formula, you got to remember one of a kind of famous theorem, the Pythagorean Theorem. And this is for right triangles. So if we have a right triangle, that is the length of each leg. So when we have right triangles, just again, let's do a little bit of terminology. The right angle is denoted by this little box in here. The legs are the sides of the triangle that are not the hypotenuse. The hypotenuse is always the side across from, directly across from the right angle. This is our hypotenuse. And these would be our legs. And so if the length of one leg was, let's say, A, the length of one leg, let's say, was B, and the length of the hypotenuse, let's say, was C, what the Pythagorean theorem says, if we take the square of each leg and sum them, so if we look at A squared plus B squared, this is going to be the same as squaring the hypotenuse. Okay, so we're going to use that fact to derive the distance formula. Okay, so let's say we have 2 points, and let them just be generic. And so let's, piece of 1, let's just call it like that, is equal to the point x of 1, y sub 1. And let our second point, piece of 2, be the point x sub 2, y sub 2. And let's just arbitrarily plot these points. And I'm just going to assume that they're in the first quadrant, but they can be in any quadrant or even on the axes. And so let's say that this point right here, oops, that should be an x sub 1, is x sub 1, y sub 1. And let's just say that this point up here was x sub 2, y sub 2. And we want to find this distance between these 2 points. Okay, well, let's look at this. And so this point right here, my x sub 1, that's where this value is right here, right? And my y sub 1 value, well, that's the height, right, of that first point. Where if I was looking at my second point, I know my x sub 2 value is right here. And my y sub 2 value is right here. This Pythagorean theorem, it wants to know what this distance is. Because this is, we're going to make this a triangle. So we're going to look at this leg here. And we want to look at this leg here, this height right there. So I need to figure out what that distance is between x sub 2 and x sub 1. Let's just look at numbers for a second. Let's say that this was 5 and this was, say, 2. Well, we know then that distance between 2 and 5 is 3. And how we get that is 5. We take the bigger of the x value and subtract off the smaller of the x value. And so this value in here is x sub 2 minus x sub 1. Same sort of idea. I can figure out what this distance is by looking at the big distance, y sub 2, subtract off the smaller distance, y sub 1, and that would give us that distance between y sub 2 and y sub 1. Okay, so this right here is y sub 2 minus y sub 1. And let's just call this D instead of C, because that's what the distance is. Let's just call that D. So by the Pythagorean theorem, we know that the hypotenuse squared, so D squared, this is equal to the length of one leg squared. Well, one leg was this value here, the distance. So x of 2 minus x of 1 quantity squared plus the square of the other leg, length of the other leg. And the length of that leg was y sub 2 minus y sub 1 quantity squared. So we've almost gotten the distance. We want distance, not the distance squared. And so we could take the square root of both sides. And so taking the square root of both sides, normally we put plus or minus in front of that square root, but because we're talking about distance, we're only talking about the positive. So we're looking at the square roots of this other side, x sub 2 minus x sub 1 quantity squared plus parentheses y sub 2 minus y sub 1 in parentheses quantity squared. So this is the distance between the 2 points. And that's our distance formula. So I know that you've used this before in other algebra classes, but you might not have seen it derived before. And so that's how we come up with that distance formula. So the example we have in front of us is find the distance between the 2 points, -3, 7 and 4, 10. We really don't need to graph this, but let's just do it anyways, just to get some more practice on graphing points. And so -3, 7, so I'm going to the left, -3, and up 7. And then I have the point 4, 10, so I'm going to the right 4 and up 10. And we want to find this distance between these two. So if we look at this, it's the change in the y value, quantity squared, plus the change in the x value, quantity squared, the square root of that. It doesn't matter which one comes first. So if I look at the change in my x value, so this 4 minus this -3 quantity squared plus the change in my y value, which was 10 minus 7 quantity squared. Well, 4 minus -3, that's really 4 plus 3, which is 7, and 7 squared is 49. Plus 10 minus 7 is 3, and 3 squared, that gives us 9. So this is the square root of 58. If there's any factor of the number underneath our radical that is a perfect square, then you want to pull it out. So 58, I know it's divisible by 2, but that's 2 times 29, and 29 is prime. So there's no factor of 58 that is a perfect square. So this is our distance. so the next example, we're given 3 points, and we want to know if we form a triangle within those 3 points, if that forms a right triangle. So again, we don't really need to plot these, but I think it's helpful sometimes just to see it. And so let's plot the point A, so -2, 2. Our point B, which is -2, 1. And C, which is 5, 4. So doesn't look like it. But let's show it mathematically that it is or is not a right triangle. Okay, so we want to sum. Well, let's figure out what the distances are. So let's find the distance between A and B. And so let's look at the change in our X value and square it. So the change in our X value will -2 minus a -2. So really -2 plus 2, quantity squared. And the change in our Y value. So 2 minus 1, quantity squared. So this would equal 0 squared, which is 0, and 2 minus 1 is 1. So 1 squared is 1, and the square root of 1 is 1. So this distance in here is just 1. Okay, so let's find the distance between C and A. Okay, so distance here between C and A. So it's a change in our X value. So 5 minus a -2. So really 5 plus 2, quantity squared. And the change in our Y. So 4 minus 2, quantity squared. So I have 7 squared, which is 49. Plus 4 minus 2 is 2 squared, which is 4. So this is equal to the square root of 53. Okay, and the last one, we want to find the distance between C and B, or B and C. So the change in our X value. So our X is for C is 5. So 5 minus the change and the X for my B value. So minus 2. So minus a -2 is plus 2. And change in my Y. So 4 minus 1. So we got 5 plus 2, that's 7. 7 squared is 49. Plus 4 minus 1, that's 3. And 3 squared is 9. So this is equal to square root of 58. Okay, so hypotenuse is always the longest side. And so looking at 1, square root of 53, square root of 58, square root of 58 is the largest value or distance. So we want to know if I take the square root of 58 and we square it by the Pythagorean theorem, it would have to hold if this was a right triangle. Is this equal to squaring one leg and summing it to the square of the other? So if we square 1 and we square the square root of 53. Well, square root of 58 squared is just 58. Is this equal to 1 squared is 1 plus the square root of 53 squared is 53. And I can see right now that 58 does not equal 1 plus 53. And so this is false. So we wanted to know did the 3 points form a right triangle? And the answer to our question is no. Because the Pythagorean theorem didn't hold true. Okay, so there's one other piece to this section, which is the midpoint formula. And so the midpoint formula is where we're trying to find the halfway point between 2 points. So if we have 2 points, let's call it point 1, which is x sub 1, y sub 1, and your point 2, let's call it x sub 2, y sub 2. I don't want to call it m because a lot of times we call m our slope. So the midpoint is equal to. So how I kind of remember this is I'm basically taking the average of the two values and finding it. So if I want to find the x value of my midpoint, I am summing my x values. So x of 1 plus x of 2, and I divide by 2. How that looks. And I have to do the same thing with my y values. I have to sum my y values together and divide by 2. And that would give us the halfway point between the 2 points given. So if we wanted to do that between the point 6, -3 and 4, 2. Okay, so again, I'm going to sum my x values. So 6 plus 4 and divide that result by 2. And I'm going to sum my y values. So -3 plus 2 and divide that by 2. Well, 6 plus 4 is 10, and 10 divided by 2 gives us 5. And -3 plus 2 is -1 all over 2, so -1/2. So the midpoint between 6, -3 and 4, 2 is 5 and -1/2. And let's just look at it. So if I was to plot 6 and go down to, so 6 -3, not 2. And 4, 2. And they're telling me that the halfway point is at 5 and -1/2. So if we look at this, and I'm not to scale, so I'm not even going to look at that one piece, but if I look at this point right here is halfway, the halfway mark. And it looks like it, just looking at it, I can see that it's on the axes. Or it's halfway in between. Okay, so that is 2.1 in your book.